Today, I'm gonna start a new topic, how to draw the internal forces diagram. Let me remind you what we learned before. We learned before that you have a beam with supported, whatever the supports, and we have external load with different shape of external loads. And I asked you to calculate the internal forces, axial force, shear force, bending moment at specific point. One point only. Do you remember? We need to do two steps. The first step, you have to figure out the reactions. The second step, you have to make cut. Then you need to decide which side I'm gonna use, the right side of your cut or the left side of your cut. Both of them works and will give you the same answer. If you decide the right side, we have reaction, we have external load, and here is your cut. At the cut, we have normal axial force, we have shear, and we have moment. Be careful. You have to assume axial force to make tension. You have to assume shear to make this part to rotate clockwise. You have to assume moment to make this part to smile. Here is the normal, here is the shear, here is the moment. And then you can apply a Coulomb equation, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. This is what we learned before. Just calculate the internal forces at one specific point. Today, we need to draw the internal forces diagram. We need to draw three diagrams. The first one, normal force diagram, shear force diagram, and the bending moment diagram. Not only one point, no, we need to draw for the whole structure, for the whole beam or the whole frame. We have few rules. We need to understand, we need to listen, we need to know this is a relationship between loading and shear. And we have a relationship between shear and moment. Please keep these relationships in your mind. Mathematically, shear equal integration of load. Moment equal integration of shear. So keep it in your mind, please, that shear is integration of load. Moment is integration of shear. So knowing the area of loading, as you remember from math, integration means area under the curve. Do you know this? If you have this parabola and you need to do integration for this parabola from this side to this side, the integration for this curve will be the area under this curve. So a change in shear is integration of load, which means the area of the load curve, the area under the load curve. And the change in bending moment will be integration of shear. So integration of shear means the area under the shear curve. If you have a shear diagram, get the area under this diagram, you can get the change in moment. If you have loading, get the area under this loading, you can get the change in shear. So please keep this relationship in your mind. Shear is integration of load. Moment is integration of shear. One more thing. So this is the first rule. The second one, I'm giving you a few hints. Guys, if you have a parabola like this, anybody can tell me where is the maximum or the highest value? Do you think the highest value is here? Do you think the highest value is here? Or the highest value is here? Mathematically, can anybody tell me how can I find the highest value? What is the highest value? Or where is the highest value? Anybody can tell me mathematically for this curve or this parabola, where is the highest value? Anybody has any idea? How can I figure out the highest value for a curve mathematically? Any answer? I can answer you. If you are looking for this point on the curve, you have a tangent. And this tangent has a slope. If you are looking for this point on the curve, we have a tangent. And this tangent has a slope. But if you are looking for this point, we have a tangent. But this tangent is horizontal. That means your slope equal 0. If you can reach to the point with tangent, and this tangent has a slope equal 0, that means you are reaching to the highest value. That makes sense? That makes sense? Guys, do you have any question for this point? Is it clear? Okay. So you are still here. That's good. So we have another rule. The maximum bending moment can be found at the slope is 0, which means at the value of shear equals 0. You know, if you assume this curve is moment, that means the slope equal differentiation of this moment. Mathematically, if you have a equation for this curve or this parabola, if you differentiate this curve, you can get the slope. Okay, we understand that differentiation of a moment will be shear. I'm sorry? Yeah, you agree that moment equal integration of shear. That means differentiation of moment will be shear. So the slope will be the shear value. When shear equals 0, you can reach the maximum value of moment. So regardless any mathematical equations or relationship, maximum bending moment will occur at the value of shear equals 0. Just keep it in your mind. If you have a concentrated load, we will expect jump in the shear diagram. If you have concentrated moment, you can expect jump in the bending moment diagram. If you have concentrated moment, you can expect vertical jump where in the bending moment diagram. If you have concentrated load, you can expect jump in the shear force diagram. The third rule. So we have only 3 rules. You need to keep them in your mind. The first one, shear integration of fluid, moment integration of shear. The second one, if you are looking for the highest value or the maximum value of bending moment, you need to search for where is the value of shear equals 0. The third rule, if you have concentrated load, we can expect jump in the shear diagram. If you have concentrated moment, you can expect jump in the bending moment diagram. We have a few steps to start to draw internal forces. The first step, you have to calculate reactions. The first step for any problem, you have to calculate reactions. Then we can start with shear. Then we can start with bending moment diagram. Let me do examples and I will go back to these rules one by one. Let's start with this one. Example number 3. Please be careful about what is the required in this problem. We need to draw what you submitted today for homework number 3 and what we learned last week. We need to calculate axial force, shear force, and bending moment. What we learned last week, calculate at one specific point, and this point will be given in the problem. But now we are looking to draw different story. We need to draw axial force, shear force, and the bending moment diagram for the shown beam. If A is a pin support, B is a roller support. Do you remember what was the first step? We have to calculate reactions. We have 2 reactions at A, XA and YA. We have 1 reaction at B, YB. Let's start to calculate reactions. We have 3 equilibrium equations. Summation f of x equals 0. What do you have in x direction? Nothing except XA. XA equals 0. So this reaction equals 0. Summation f of y equals 0. So we have YA minus 20 plus YB equals 0. So I can say YA plus YB equal 40. Summation moment at any point equals 0. I'm gonna take moment at A. I'm assuming this direction is positive. So what do you have? Moment at A, that means XA times 0. We don't have distance. YA times 0, we don't have distance. 20 times 6. The other 20 times 12. And then YB times 15 equals 0. This term will be cancelled, this term will be cancelled. The only unknown in this equation will be YB. So, using my calculator, 20 times 6, 20 times 12, divide 15, 24. If you go back and put YB equal 24, I can figure out the value of YA. It will be 16. So finally, YA equals 16, YB equal 24. Any questions so far? Reactions. Without reactions, you cannot finish up this problem. Reactions. Okay. The next step, I will draw vertical lines at any load, any reaction from the beam, like this. And I will draw 3 copies for this beam. The first one will be called normal force diagram. The second one, shear force diagram. The third one, bending moment diagram. So this one will be called normal force diagram. This one will be called shear force diagram. This one will be called bending moment diagram. Guys, do you remember what are the forces cause axial? If you remember, is horizontal. So which force will cause axial? I'm gonna start with the left side. If you have a force parallel to the member, like this or like this, do you have a force parallel to this beam at left? Yes, we have. Which one? XA. How much? XA. How much? 0. That means your normal force diagram is 0. We don't have force. We don't have a force parallel to this beam and has a value. The only force is XA, and XA is 0 from reaction calculations. To draw your shear force diagram, we need to start from left side. And we need to go up, which is positive, if the force goes up. And vice versa. That means I'm gonna go down, which is negative, if the force goes down. One more time. One more time. For shear force diagram, I have to start from left. I will go up if the force goes up. I will go down if the force goes down. Let's do it. Where is your left? Here is the left. Which force is going up? YA going up. How much? 16. So I'm gonna go up 16. Walk. Do you have anything when you are walking? Do you have anything here? Do you have anything to go up or go down? No. So keep going constant until you reach 20. Remember, you are at 16 value. Please pay attention to me. Please pay attention. Leave your pencil or your pen and pay attention. I'm starting from left. What do you have? We have YA equals 16 going up. So I went up by 16 and then walking constant until you hit anything else. Until this distance, we don't have anything. So I walked constant until you hit 20. 20 is going down. Remember, you are at 16. If you go down 20, I will reach 4. That makes sense? 4? Yeah. Because this is 16 and this is 4. So the total will be 20. That makes sense? Keep walking. You are at 4. Nothing here. So I'm gonna walk constant. Remember, you are at 4. At this point, I will go up or down. Because you have 20, I will go down. One more time. Because we have 20 going down. You are at negative 4. You are at negative. This value is negative 4. you need to go down more 20. So I will reach 24. Keep walking until the end of the beam. What do you have at the end? We have a vertical reaction going up. So I will go up. How much? 24. You are at 24. If you go up 24, you can hit 0. This diagram will be positive because it's up. This diagram is negative. This diagram is negative. I am done with the shear force diagram. If you have any question, let me know. If you have any question, let me know. Let's do one more example. I didn't do bending moment diagram, just I will go back one more time to figure out the bending moment diagram. So don't worry. I will go down one more time here for bending moment diagram. But I will do this example. We need to draw axial force, shear force, and the bending moment diagrams. A is a roller, B is a hinge. First step, we need to figure out the values of reactions. We have one reaction at A, YA. We have two reactions at B, YB, and XB. Let's start. Summation f of x equals 0. We have negative 8. We have, positive 8. It's positive. We have negative xb equals 0. So xb will be 8. Summation f of y equals 0. We have YA plus YB going up. We have negative 6. We have negative 8 going down equals 0. So YA plus YB equal 14. Third equilibrium equation, summation moment at any point equals 0. I will get moment at B. I'm gonna assume this direction is positive. You can assume what you want. So guys, please pay attention and don't do the mistake one more time. If you are taking a moment at B, XB does not have distance. YB does not have distance. 6 kilonewton does not need distance. And this one will be negative, because you assume counterclockwise is positive, so this one is clockwise, so it will be negative. This one more time, does not need distance, because it's a moment. 6 kilonewton is a moment. What else? What else do you have? We have positive 8 times 2. We have positive negative YA times 4. We have positive 6 times 8 equals 0. I believe this term will be cancelled, this term will be cancelled. The only unknown in this equation will be YA. So the value of YA will be 14.5. If you put here YA equal 14.5, I can figure out the value of YB. It will be negative 0.5. Does that make sense? YB, let me do it one more time. 8 times 2, 6 times 8, divide 4. Yes. Okay. So the final conclusion, YA equal 14.5, YB equal 0.5 to down. Because negative means you assume the wrong direction, it will be down. And the XB equal 8. So please be careful about reactions. Then to draw, I will draw vertical lines at anything in the beam. Then I will draw 3 cubes of the beam. One for normal force diagram, one for shear force diagram, one for bending moment diagram. Let's start with the normal. I'm gonna start from left. Here is the left. Do you have a force? The question is, do you have a force parallel to this beam at the left side? The answer is yes or no. Do you have a force parallel to this beam at the left side? Yes, we have. How much? 8. Second question. This 8 pushing the beam or pulling the beam? Pushing? Pushing means compression. Compression means negative. So we have a negative here, 8. This 8 will be constant to the end of the beam. The previous example, the question is, do you have a force parallel to this beam at the left side? Yes, we have. XA. How much? 0. So your normal force or axial force diagram is 0. We don't have any force parallel. But for this problem, we have a force, 8. That means we have a value. This 8 pushing or pulling the beam. Pushing. Pushing means compression. Compression means negative. Negative means down. Any question? Guys, do you have any question? If you have any question, let me know. If you have any question, let me know. Okay, for shear force diagram, we will start from left. I will go up if the force goes up. I will go down if the force going down. Do you have any force at this left going up or going down? Yes, we have. How much? 6. Going up or down? Down. So I'm gonna go down 6. Keep walking constant until this point. You have YA equal 14.5 going up. So I'm gonna go up how much? 14.5. So I'm gonna reach to 8.5. Then walk constant until you hit 8. You are at 8.5. If you go down 8, I'm gonna reach 0.5. Keep walking constant at 0.5 until you hit the last reaction going down. How much? 0.5. If you go down 0.5, you can reach to 0. This diagram is negative, this diagram is positive, this diagram is positive. That makes sense? That makes sense? Guys, just to remind you, if you have concentrated load, we can expect jump in the shear diagram. You have concentrated load here, so we have jump. You have concentrated load here, so we have jump in the shear force diagram. You have concentrated load here, so we have jump. We have concentrated load here as a reaction, so we have jump in the shear force diagram. That makes sense. So guys, right now I'm looking to draw the bending moment diagram. I'm looking to draw the bending moment diagram. At free ends and at simply supported ends, the moment will have 0 value. This point is very important. We are going to start from left. If you have free end or hinge support or roller support, no moment, no moment, no moment. We don't have moment at this free end or simply supported end. Your moment equals 0. If you have free end, if you have fixed support at the left side, that means the moment will have a value equal the reaction moment value. If you have fixed at this side, that means we have 3 reactions. So we have a moment equal value. That means moment at this point equal to this value. Positive or negative based on the direction. Clockwise is positive and the counterclockwise is negative. The value for the shear diagram, if there is a value for the shear diagram, we have a change in moment. Let's do it one by one. Let's do it first with this example. I'm gonna start with the left side. This left side, what is the category of this left side? Do you have fixed support? No. Do you have free end? Yes. What is the value of moment? 0. It's a very simple question. It's a very simple question. If you have free end, no support. If you have hinge support, if you have roller support, your moment equals 0. If you have fixed support, your moment equal the moment reaction. So please ask yourself this question. At this left, what do you have? We have free end. So your value of moment equals 0. I'm looking for the value of moment at this point and the value of moment at this point. and the value of moment at this point. So M1 equals 0, M2, I'm not sure, M3, I'm not sure, M4, I'm not sure. Let's start. M equal M at the previous point plus area of shear diagram in between. This is the rule to figure out the moment at any point. Moment at any point equal moment at the previous point plus area of shear between the 2 points, this point and this point. I cannot figure out this rule. Okay, let's start. M2. We are looking for M2. What is the value of M2? Equal to what? Previous moment or moment at the previous point. What is the moment at the previous point? M1, how much? 0. Plus area of shear diagram between the 2 points. Here is the first point. Here is the second point. Do you have shear diagram between? Yes, we have this diagram. Can you tell me what is the area of this diagram? Yes, I can. What is the area? The length is 4. This height is 6. This diagram is negative. So we have negative 4 times 6. What is the final value? Negative 24. So your moment here will be negative 24. Anybody can tell me what is the value of M3? We are looking for moment at point 3. Moment 3. What is the rule? The moment at the previous point. What is the previous point for M3 is M2. How much? Negative 24. Plus. Do you have a shear diagram between this point and this point? Yes, we have. This diagram. Can you tell me what is the area? This height, 8.5. This length, 2 meters. This diagram is positive. So we have positive 8.5 times 2. What is the final value? Negative 7. So the value here is negative 7. M4. Can you do it? What is the value of M4 equal? Previous value for this point will be M3, negative 7. Plus, you have shear diagram between this point and this point? Yes, we have this area. It's positive 0.5 times 2. Your value will be negative 6. So we have a value here, negative 6. Go ahead and draw or connect between this value and this value, this value and this value, this value and this value. This diagram will be negative. This diagram can be called bending moment diagram. One more time. Let's do it one more time. Can we do it for the previous problem? We need to draw bending moment diagram. Believe me, this diagram is nothing, just for fun, based on the shear force diagram. I'm gonna start from left. What do you have at your left? Do you have fixed support? No. Do you have hinge support? Yes. What is the value of moment? 0. So your value of moment here would be 0. M1. We are looking for M2. We are looking for M3. We are looking for M4. M2 is unknown, M3 is unknown, M4 is unknown. M1 equals 0. That makes sense. Let's start with M2. Value of M2 equal previous value for M2 is M1. How much? 0. Plus, do you have shear force diagram between the 2 points? This point and the previous one? Yes, we have. This diagram. This diagram has an area equal 16 times 6. Positive. Your value is 96 positive. So the value of moment here will be positive 96. Positive. The next value, M3, equal previous value for M3 is M2. How much? Positive 96. Plus, do you have shear diagram between the 2 points, this point and this point? Yes, we have this area, which is negative. What is the area? 4 times this length 6. So we have negative 4 times 6. 72 positive. So we have here positive 72. Last point, M4. What is the value of M4? Previous value for M4 is M3, positive 72. Plus the area of shear in between. Do you have area of shear? Yes, this negative area. How much? 24 times 3. Negative 24 times 3. Your final answer will be 0. Okay? 0 is a number. So we have a value here, 0. Go ahead and connect between this value and this value, this value and this value, this value and this value. Here is the bending moment diagram. This diagram is positive. So guys, do you have any question? Let's do this example. One more time. One more example. One more example. We need to draw normal force diagram, shear force diagram, bending moment diagram for the shown beam. We have only one support, A is fixed. That means we have 3 reactions, YA, XA, MA. The first step to draw these diagrams, we have to figure out the reactions. We have 3 equilibrium equations. Summation f of x equals 0. So we have XA equals 0, nothing else. We have summation f of y equals 0. So we have YA minus 8 minus 3 equals 0. So YA will be 11. Summation moment at any point equals 0. I'm gonna take moment at A. I'm gonna assume this direction is positive. Guys, I'm still repeating. Please don't do this mistake. Taking a moment at A, XA does not have distance. YA does not have distance. Negative. MA does not need distance. Because MA is a moment. Does not need distance. Plus 8 times 2 plus 3 times 4 equal 0. This term will be cancelled. This term will be cancelled. The only unknown in this equation is MA. The value of MA will be 28. So this value is 28. This value of reaction equal 11. To draw the diagrams, I'm gonna draw vertical lines at anything in the beam, any change. Then I'm gonna draw 3 copies. One for a normal force diagram, one for shear force diagram, one for bending moment diagram. Let's start with the normal force. For any diagram, I'm gonna start from left. Do you have force parallel to this beam at the left? Yes, we have. What do you have? We have XA. How much? 0. Your normal force diagram is 0. Please write 0. For shear force diagram, I'm gonna start from left. Do you have a force going up or going down? Yes, we have. How much? YA. How much? 11. Going up? Yes. I'm gonna go up 11. Walk constant until you hit 8. So I will go down 8 until reach 3. Then keep walking constant until you hit the last force 3 going down. So I will go down 3 to reach to 0. Here is the shear force diagram. For bending moment diagram, I'm gonna start from left. The question is, do you have a fixed, or you have free end, or hinge, or roller? What do you have in this case? We have a moment. We have a fixed. We have fixed support. We have fixed support. So we have a moment. Your moment here is not 0. Your moment here equal this moment as a reaction. So this moment equal 28. Positive or negative? At the fixed support, the moment value will equal the reaction moment. Clockwise is positive, counterclockwise is negative. What is the direction of moment here? This direction is clockwise or counterclockwise? It's counter. So we have a negative value here, 28. So M1 equal negative 28. We are looking for M2. We are looking for M3. Guys, please pay attention. I'm looking for the left side of the beam. What do you have? In our case, we have fixed. That means at this location, we have a moment. This moment equal to the reaction moment. Positive or negative based on clockwise direction is positive, counterclockwise direction is negative. This direction is counterclockwise, so it will be negative 28. What is the value of M2? Previous value. What is the previous value for M2 is M1 negative 28. Plus area of shear between the 2 points. Do you have shear between? Yes. Yes, we have. Between this point and this point, we have this diagram. What is the area? 11 times 2 positive. So your value will be negative 6.
I have a question.
Yeah.
Is that not clockwise, what you assume? The 28?
Yeah, I assumed it counterclockwise. No. I'm talking about the reaction, not talking about the equation for the moment.
Oh, okay, I see.
I'm talking about this direction for the reaction as a moment.
Okay, I see.
I'm not talking about what I assumed to set up this equation. Okay.
All right, I see. Thank you.
Yeah. So this value M2 equal -6. So we have a value here, -6. M3, previous value for M3 is M2, -6. Plus, what is the shear diagram between this point and this point? This little area, positive, how much? 3 times 2. Your value is 0. Okay, that makes sense. So we have a value here 0. We have a value here -6. We have a value here -28. Go ahead and draw lines in between. This diagram is negative. So guys, it's very simple. But the first step, you need to figure out the reactions. And believe me, if your reactions are wrong, everything will be wrong. Typically, you should have 0 if you cannot calculate reactions. Because if you cannot calculate reaction, you don't have the right to pass this course. So reactions, then axial force is very simple. Do you have any force parallel to the beam? If you have, okay, go ahead and put it. If you don't have, we have 0. For shear force diagram, I'm looking for any force going up or going down. Very simple, looks like a toy, piece of cake. The bending moment diagram needing some attention, because this bending moment diagram is based on the shear, but you have to start. What do you have at this point? Right now we have 3 cases. For the first one, we have hinge. We don't have moment. Second case, we have free end. Free. We don't have moment. Third case, you have a fixed. This fixed will have a moment because you already have a reaction moment. So based on this reaction as a moment, we have a value here. This value is positive or negative based on the direction of this reaction. Direction of MA. In this case, this direction is counterclockwise, so it's negative. And then we can figure out the rest of the diagram. Guys, do you have any question? If you have any question, let me know. If you have any question, let me know. Okay, let's do example number 6. Example number 6. We need to draw axial force diagram, shear force diagram, bending moment diagram. At A, we have hinge. So we have 2 reactions, YA and XA. I'm going to assume XA like this. It's your freedom. You can assume what you want. At B, it's a roller, so I'm going to assume a reaction at BYB like this. Before starting to figure out the reactions, we need to do something. The first one, what is the equivalent value for this distributed load? Guys, the last homework, there is a student. He or she, I'm not sure, still saying the equivalent value here is 4. Which is equal to this 4. That's wrong. That's wrong. This distance, by the way, is 4 meters. I forget it. This equivalent load is not 4. This equivalent load is 4 times this horizontal distance 4 is 16 kilonewton. Okay? There are few things are important. Without these things, that means you are not familiar with structure analysis. So you have to wait a little bit for another semester to learn these rules. So be careful. So the equivalent load value equal 4 times 4 is 16. And we have inclined force. This inclined force will be broken to two components, one vertical and one horizontal component. We don't have angle, but we have a right angle triangle. Let me do it here in more details. We have this force, how much? 20. We have this incline 3, 4, and 5. We need to figure out the horizontal component and the vertical component. Let's do it. If you assume this angle theta, so this component will be 20 cosine theta. This component will be 20 sine theta. I believe this angle theta equal to this angle theta. Anybody can tell me from this right angle triangle, what is the value of sine? What is the value of cosine? Sine 4/5, cosine 3/5. So 20 times 3/5 equal 12. 20 times 4/5 equal 16. So the vertical component will be 16. The horizontal component will be 12. Any question? Any question? We have three equilibrium equation. Summation f of x equals 0. We have negative xa. We have positive 12 equals 0. That means xa will be 12. I assumed the correct direction. Summation f of y equals 0. We have ya plus yb minus 16 minus 20 minus 16. 16, 20, 16 equals 0. So ya plus yb equal 52. Third equilibrium equation, summation moment at any point equals 0. I'm gonna take moment at A, and I'm gonna assume this direction is positive. Please pay attention. Taking a moment at A, xa does not need distance. Ya does not need distance. 16 times 2. This 16 times this little 2. Plus 20 times 4. Plus or minus yb. Minus yb times 8. Plus 16 times 11. Plus 150 does not need distance. This 150 is a moment, does not need distance. Plus 12 times 0. Remember, this 12 is a horizontal force. So we are looking for vertical distance. Do you have any vertical distance? No. Equals 0. So this term will be cancelled. This term will be cancelled. The only unknown in this equation is yb. Yb equal 54.75. 54 times 0.75. If you put yb with this value, I can figure out the value of ya will be negative 2.75. So the final conclusion, YB equal 54.75 and YA will be down, not up, because it's negative 2.75. Vertical lines at this equivalent load, vertical lines, vertical lines, vertical lines. We need to draw 3 copies. Normal force diagram, shear force diagram, bending moment diagram. Here is the left side. Do you have any force parallel to this beam? Yes. XA. How much? 12. Pulling or pushing the beam. This direction is pulling or pushing. This direction related to this beam is pulling, so it's tension. So we have positive value 12. This 12 will be constant to the end of the beam, so we have positive 12. Very easy. For shear force diagram, I'm gonna start from left. Do you have any force going up or down? Yes, we have force going down, 2.75. Because you are walking inside uniform distributed load, so I'm gonna walk, but dotted, until you hit 16. So I will go down 16 until 18.75. Then constant. You have another 20, so I will go down 20 to reach 38.75. Constant. We have a reaction here, 54.75 minus 38.75. So I will go up to 16. Keep walking constant until the end of the beam. You have 16, so I will go down to 0. From the first point of the dotted line and the end point, I'm gonna draw solid line like this. Positive, negative. Here is the shear force diagram. We are still looking for bending moment diagram. I'm gonna continue next meeting to repeat these rules and how to draw bending moment diagram if you have uniform distributed load.